Hello everyone, welcome to my channel Physics Tricks. So let's continue with our current electricity DPP, and in this we have first problem. A wire of radius r has resistance capital R. If it is stretched to a radius r by 2, its resistance will be. So when resistance wire is given of a radius r, okay, now it is stretched so that its radius becomes r by 2. Okay, radius becomes r by 2. So for the first wire we have the resistance, and that is equal to rho L is the length of the wire into the area A, and for the second wire r dash is equal to rho L dash divided by A dash. That indicates what? That indicates the resistance depends on length and area of cross section. So as area decreases, length will increase, isn't it? So, but the volume will remain same. So over here, area times length is equal to the A dash times L dash. So which is equal to area times length is equal to, what is A dash over here? It is pi r squared divided by 4 into L dash. But pi r square is nothing but A only. So AL is equal to A by 4 into L dash. So what is L dash over here? 4L. So the area for this we have is A by 4, and the length we have is 4L as compared to the initial one. So the R dash we can write it as rho 4L divided by A by 4. So as you can see, this is 16 rho L divided by A. So what is rho L divided by A? Just now we have seen, and that is the resistance of the first wire. So R dash, that is the final resistance, is 16 times the initial resistance. So I hope this is clear now. 16 times the initial resistance. So option A is the correct option for this question. Chalo, the next question we have, and this is the second question, and it came in 1997 competitive examination, and here it is given a battery of EMF 20 volt. This is what 20 volt given, and internal resistance 6 ohm. So we'll draw the internal resistance as 6 ohm is connected to a resistance as shown in the figure. If current in the circuit is 1 ampere, so current in the circuit is 1 ampere given, the resistance of a resistor will be, so this resistor R is equal to what? That is what we have to find out. So current is given, right, and this resistance we want, so we can apply the Kirchhoff's voltage law over here. So what is Kirchhoff's voltage law? In a loop, right, Kirchhoff's voltage law. So I'll explain over here a little bit about the Kirchhoff's voltage law. Kirchhoff's voltage law is nothing but in a loop, sum of all potential differences across the batteries and the elements as in what? Resistor is there, capacitor is there, inductor is there, right, are 0. Sum of all the potential differences across the batteries and the elements are 0, right. So here if you consider the loop A, B, C, D and A again, so in a loop A, B, C, D, A, we can apply A to B, nothing is there, B to C, we have this is positive, this is negative. So current 1 into R, so here R voltage is there, so minus R volt. And one more thing, if you go from positive terminal towards the negative terminal, we are dropping the potential. So whenever you go from positive to negative, we are dropping the potential. Dropping indicates what? Dropping indicates we have to consider negative. And if you go from negative towards positive, it is the gaining the potential. Gaining indicates you have to consider positive potential over there. Okay now. So positive to negative dropping, so negative to positive gaining, that is positive. Now you can write this as positive to negative, you can consider gaining, and that you can write at positive. But yes, this is my sign convention, so according to me, this if I go from positive to negative, it is the dropping, and if I go from negative to positive, it is gaining. So I am going from positive to negative, that is B towards C, positive towards negative, dropping, so minus R. C to D, nothing is there. D to A, two elements are there, 6 and 20 volt. So it is positive, this is negative. Current direction is always flows from higher potential to the lower potential. Current direction is in this way. So dropping again, so minus 6 into 1, 6 volt. Then here the smaller terminal negative, bigger terminal positive. Then gaining plus 20 is equal to 0. Plus 20 is equal to 0. So from this R we have is 20 minus 6, that is 14 ohm. So that is what, once you understand the basics, these problems are nothing. These problems are nothing once you understand the basics. So second, we have what is called as the A option. So next question we have, this is the third question. The value of current I in the circuit as shown in figure is, okay, so value of current I in the circuit we want. So I value, that is the current flowing through this circuit, that is what we want. Okay, so this is 3 volt, indicates across this resistance we have 3 volt. Why? Because the voltage in parallel will remain same. So across this combination of all this, that is 5 plus 5 plus 5, it will become 3 volt only. So what is the current through this? Current will be I is equal to voltage across this resistance 3 divided by the resistance, that is 5 ampere. Likewise, current across this 555 is voltage across this 3 divided by total resistance is 15, which is 1 divided by 5 ampere. And if I apply what is called as the Kirchhoff's voltage law at node A, Kirchhoff's current law, I'll just explain, I'll just give the idea what is Kirchhoff's current law. Kirchhoff's current law, or else we can say this as node or else junction law. Okay, now junction law. So it is applied at a node, and it says whatever current incoming is there and whatever current outgoing is there, these currents are equal. So sum of, at a node, right, at node, sum of incoming current must be equal to outgoing current. Okay, now sum of incoming current must be equal to outgoing current. That is what the Kirchhoff's current law is. So over here, Kirchhoff's current law, I incoming we have, and that is equal to the outgoing current I1 plus I2, that is 3 by 5 plus 1 by 5, which is equal to 4 by 5. And if you just solve this, you will get 0.8 ampere. And as you can see, this is given in option B. So I hope this is clear. And this Kirchhoff's current law is based on the law of conservation of charges. This is very important. And Kirchhoff's voltage law is based on the law of conservation of energy. Okay, now. So these two statements you need to remember. So I hope this is clear. Now the next problem we have, and that is fourth one. Electroplating is not provided to be used for. So it is not provided to be used for shining appearance, protection of metal against corrosion, fine finishing to the surface, hardening the metals. Okay, so it is not provided to fine finishing to the surface, right? It is not provided to the fine finishing to the surface. It is for shining appearance, true. Protection of metal, true. Hardening of metals, true. It is only fine finishing to the surface. This is not at all true. Okay, so this is option C we have. So I hope this is clear. Theoretical question. Fifth one, in the given figure, the equivalent resistance between 2 points A and B will be. So over here we want what is the equivalent resistance between A and B. So I'll just draw the circuit over here. This is 2 ohm we have. This is 4 ohm. This is 4 ohm. And this is 2 ohm. So 4 ohm, 4 ohm, 2 ohm and 2 ohm. This is A. This is B. So 4 ohm is in parallel with 4 ohm. It will become 2 ohm. This 2 ohm, this 2 ohm, this 2 ohm. They are in series. So the equivalent resistance between A and B is 2 plus 2 plus 2. That is equal to 6 ohm. So I hope this is clear to you all. Now the next problem. Given a current carrying wire of non-uniform cross section, which one of the following is constant throughout the length of the wire? Okay, so we have a wire of non-uniform cross section like this, right? So at this point we'll consider A, this is B and this is C. So if you consider current at A is I1, current at B is I2 and current at C is I3. The drift speed at A is Vd1, drift speed at B is Vd2, drift speed at C is Vd3. Electric field at 1 is E1, electric field at 2 is E2, electric field at 3 is E3. So what is the relation now? See here. Now we know that in a series, current will always remain same. So we can say current I1 which is equal to I2 which is equal to I3. This will remain same throughout the conductor. Okay, throughout the conductor current will remain same. Now what about the drift speed? Drift speed, we know that drift speed we have is current I is equal to NEAVD. Just now we have seen I is constant, N is constant, E is constant. So what is area into drift speed? It is constant. Indicates if area changes, drift speed changes. Yeah. So drift speed at 1. So if you consider this area at A, area at B and area at C. So area at A is lesser than the area at B. Therefore, drift speed at 1 is greater than the drift speed at 2. So likewise you can have the relation, right? And we know that the electric field and the drift speed relation is drift speed is directly proportional to electric field. So therefore electric field at 1 is greater than the electric field at 2. So this is the relation which we have. So here only the current will remain same, drift speed and the electric field will change according to area. So you can write note only current changes, current remains the same throughout the length of the conductor drift speed and electric field will change with respect to area. If area changes, drift speed and electric field changes. So I hope this is clear. This is clear. Now the next problem, that is the seventh problem we have. The current in the circuit is okay. So over here, this A terminal and B terminal is not at all connected to any battery. That means in this we have only one current. Okay. So we'll consider current direction in this way, I. So in this way it is I. In this way it is I. In this way it is I. So this is plus minus. This will be 10I. This is plus minus. This will be 20I. This is plus. This is minus. This is plus. This is minus. So I'll go from point A towards point B, then to C, and then to D, and again to A. So in a loop A, B, C, D, A, we can have A to B. If you go, it is the dropping the potential firstly, so minus 10I, then again gaining plus 5, then dropping minus 20I, then dropping minus 2 is equal to what? 0. So it is 30I is equal to 3. So what is I then? It is 0.1 ampere. So I hope this is clear. So answer for this is 0.1 ampere. Okay, so next problem. The cell has an EMF of 2 volt and the internal resistance of this cell is 0.1 ohm. It is connected to a resistance of 3.9 ohm. The voltage across the cell is. Voltage across the cell when the cell is supplying the current is called as the potential difference. So the difference between the EMF and the potential difference is, see, EMF is nothing but it is the voltage across the battery when the battery is not supplying any current is called as EMF. Okay, and what is potential difference across the battery? It is the voltage across the battery when the battery is supplying the current. Okay, so over here, as the battery is supplying the current, we want the potential difference across the battery, right? So voltage across the cell. So cell we have, this is the cell, and the internal resistance cell of EMF is given 2 volt and internal resistance 0.1 ohm, which is connected across 3.9 ohm resistance. So what is the current in this cell? So current I is equal to potential difference 2 divided by the total resistance in the circuit, and that is 3.9 plus 0.1, which is equal to 2 divided by 4, which is equal to 1 by 2 ampere. So current we have is 0.5 ampere in this circuit. We want what is the potential difference across this battery, right? So this is the battery which consists of the EMF and the internal resistance. So we'll start with VA. So it will be VA. This is plus, this is minus, this is plus, this is minus. Minus 2 plus 0.5 into 0.1 is equal to VP. So we want VA minus VP, that is the potential difference. That is the voltage across the cell. So 2 minus 0.05, which is equal to 1.95 volt is the potential difference across this battery, and it is given in the option A. So I hope this is clear. Chalo, next problem. This is the 9th one. The resistance between A and B is okay. So this is the infinite ladder given. So I'll just draw the circuit as it is over here. Firstly, so we have, this is the electrical circuit given. And this is till infinity we have. Now, if I consider this point A, this point B, this point C, and this point D, now tell me, if I take the, if I want the equivalent resistance between these 2 points, that is A and B, what is the equivalent resistance? It is equivalent resistance, let us consider, that is X. Now, if I consider the equivalent resistance between C and D, what is the equivalent resistance? What do you think? What is the equivalent resistance if I just remove one part of it? It must be same, right? X. Why? Because it is still infinity. If you remove one from the infinity, nothing will happen, isn't it? So between C and D, if you see, it is R equivalent, that is X only. So we can redraw the circuit, and it will be, this is R, this is R, this is R, and between C and D points, we have what is called as the R equivalent, and that is X. This R equivalent is still there, and that is X only. So what is the combination of these two? It is the parallel, so XR divided by X plus R. plus this R and this R, they are in series, so it will become 2R is equal to X. Why? Because it is R equivalent. Now if you just cross multiply and solve, it is XR plus 2XR plus 2R squared is equal to X squared plus XR. Now take this 2XR this side, that is 3XR this side. So it will become X squared minus 2XR minus 2R squared must be equal to 0. Now this is the equation quadratic in X. So therefore the roots are x1 comma x2 and that is equal to minus b, that is 2r, plus or minus square root of b squared minus 4ac, that is 4r squared plus 8r squared divided by what is called as twice a, so 2. So if you just solve this, 2r plus or minus root of 12r squared divided by 2, and as you can see over here, we can take this 2r plus or minus, this is 2r common, root of 3 divided by 2. So we'll have this 2r divided by 2 in bracket 1 plus or minus root 3. This 2 get cancelled. R in bracket 1 plus or minus root 3. Resistance negative not possible, and that is the reason we have X, and that is R equivalent, and that is equal to R in bracket 1 plus root 3. So I hope this is clear. 1 plus root 3 into capital R. So answer for this question we have is 1 plus root 3 into capital R. So option A is the correct option. Now the next question, and this is the last question we have, 10th question. What is the equivalent resistance across A and B in the figure shown? R is equal to 3 ohm given. Okay. So as you can see, this is A point given, this is B point given. From A we have resistance R, then this is resistance R, again this is resistance R, and we have triangle like structure like this, and we have this is again R and R. This R and this R, they are in series, it will become 2R which is in parallel with this R. So therefore we have R equivalent for parallel combination is 2R into R divided by 3R. So RR get cancelled. 2 by 3 R we have. This is the R equivalent for the parallel combination. Therefore 2R plus 2 by 3R is what is called as total equivalent resistance we have. So it is 8R divided by 3 is the equivalent resistance between A and B. So answer for this is 8 divided by 3 into 3, because R is given 3 ohm. So you will get it as 8 ohm is the answer. So I hope this is clear. So answer for this question is 8 ohm. Now if anybody has any doubt in the equivalent resistance one from any book, they can comment on this video. I'll try to solve that question in the next video. Thank you so much.